NASA, the United States Space Agency, recently conducted a test flight of its newest supersonic aircraft, designed to address one of the major problems of supersonic flight: the noisy supersonic boom, or sonic boom. Hello everyone, welcome back to Military Notes. The aircraft is the X-59 QueSST, Quiet Supersonic Technology, part of a larger NASA project to develop aviation technologies that can minimize the environmental impact, especially noise, of aircraft flying faster than the speed of sound. History and purpose of the X-59 QueSST project. The X-59 project began in 2016 as part of Langley's low-boom flight demonstration program, which aims to test and develop technologies that would allow aircraft to fly at supersonic speeds without producing the loud noise typically associated with the sonic boom phenomenon. Sonic booms are loud sounds produced when aircraft pass through the sound barrier, which have detrimental effects on the environment, property, and human comfort. While supersonic flight can significantly reduce travel time between countries, the sound of this supersonic boom has been a major deterrent to commercial supersonic flight. The X-59 QueSST is designed with a very specific aerodynamic shape to reduce this noise. With a long, slender body and narrow wings, the aircraft is designed so that the pressure waves that typically produce sonic booms are broken up into much softer, less disruptive sounds. Instead of a loud boom, the X-59's flights are expected to produce only a thump or poof sound, which is barely audible to people on the ground. Design and technology. The X-59's design is based on a distinctive needle nose shape, with a very long, narrow front section, followed by larger, low-flying wings. This design allows the airflow around the aircraft to remain smooth, preventing the formation of large shock waves that usually cause the booming sound when the aircraft exceeds the speed of sound. The aircraft is powered by turbofan jet engines, which reduce engine noise, and has a body shape that allows the aircraft to travel faster with greater fuel efficiency than conventional supersonic designs. At about 29 meters, 90 feet long, the X-59 is larger than a typical passenger jet, but is still much more streamlined than any other existing supersonic aircraft. One of the X-59's key features is its ability to fly at speeds in excess of Mach 1.2, about 1,500 kilometers per hour, which allows it to cover long distances in a shorter time without the noise disturbance common with previous supersonic aircraft. First test flight. After years of development and laboratory testing of the design, as well as building prototypes, NASA finally conducted its first test flight of the X-59 in early 2025. The first test flight was conducted at Edwards Air Force Base, California. While the aircraft did not perform supersonic flight during the initial test phase, the primary focus was to test the aircraft's stability at subsonic speeds and ensure that the aircraft's systems were functioning properly. This first test flight provided important data on the aircraft's aerodynamics, stability, and control. NASA hopes that through this series of tests, the X-59 can successfully reach supersonic speeds without making any noise that could disturb people in the flight path. Testing over civilian populations. One of the most exciting aspects of the X-59's testing is NASA's plan to test it over civilian areas, which have previously been off-limits to supersonic aircraft. With this new technology, NASA hopes to reopen supersonic flight to commercial use. In the next phase of testing, the X-59 will fly over several urban areas to collect data from residents in its flight path. NASA will use sensors to measure the noise the aircraft makes and then validate whether the noise is what it's supposed to be, that is, not disruptive. Researchers will gather feedback from local residents about whether they can hear the noise and how much they are bothered by the noise. This is a critical step in convincing regulators and the public of the potential benefits of quieter supersonic flight. Impact on the aviation industry. The success of the X-59 will pave the way for a new era in the aviation industry, where supersonic aircraft can be used more widely, including for commercial flights. Companies like Boom Supersonic and Ariane, who are also developing supersonic aircraft, will benefit from this technology. With the ability to fly faster without producing disruptive noise, supersonic aircraft could enable much faster international travel, reduce flight times between distant major cities, and have a significant economic impact. Looking ahead, the development of aircraft like the X-59 is expected to bring about a major shift in the way we think about air transportation. While there is still a long way to go before aircraft like the X-59 can be widely used, this test is a significant first step towards greener and more efficient supersonic flight. With the first test flight of the X-59 QueSST, NASA has demonstrated significant progress in the technology of quieter supersonic flight. With an innovative design that reduces supersonic boom noise and testing conducted over civilian areas, this project has the potential to change the landscape of commercial aviation in the future. While still in the early stages of development, the X-59 opens the door to the possibility of more environmentally friendly and more efficient supersonic flight on intercontinental journeys. X-59 QueSST, the silent supersonic aircraft of the future. The X-59 QueSST, Quiet Supersonic Technology, is a revolutionary supersonic aircraft project developed by NASA with the goal of overcoming one of the major obstacles to commercial supersonic flight: the sonic boom. The aircraft is designed to enable supersonic flight without the annoying noise, providing new hope for a faster and more efficient future of international aviation. The X-59 QueSST is expected to change the way we travel, revolutionize long-distance flights, and pave the way for more environmentally friendly and comfortable future aviation technologies. Project background. Supersonic flight has been a dream of engineers and scientists for more than a century. However, while aircraft such as the Concorde have operated at supersonic speeds, a major obstacle to the widespread adoption of supersonic flight is the noise produced when aircraft exceed the speed of sound. This supersonic boom, known as a sonic boom, can cause damage to property and disrupt the daily lives of people in the aircraft's flight path. To address this issue, NASA began development of the X-59 QueSST aircraft as part of its low-boom flight demonstration program, which aims to test technologies that could reduce or even eliminate the noise impacts of supersonic flight. The project aims to create an aircraft that can fly faster than the speed of sound, but with much lower noise, allowing supersonic flight over populated areas without disruption. Design and technology. One of the most striking features of the X-59 QueSST is its unique aerodynamic design. Unlike traditional supersonic aircraft that have thick, powerful shapes, the X-59 is designed with a long, slender shape that resembles a needle nose. The aircraft is about 29 meters long and has a very narrow wingspan, which is designed to reduce the formation of large shock waves that usually produce supersonic boom sounds. This design aims to break up incoming air waves in a more controlled way. Instead of loud, deep shock waves, the airflow around the aircraft is designed to produce a softer sound, such as a thump or poof that is barely audible to people below it. This process utilizes advanced aerodynamic principles and technology that can direct airwaves in a way that reduces the pressure and disturbance that usually occurs when aircraft fly faster than sound. In addition, the X-59 is equipped with turbofan engines that are more efficient and produce less noise than conventional jet engines. This also reduces the environmental impact and noise that is usually associated with supersonic aircraft flight. With this design, NASA hopes to develop a faster and more efficient aircraft, but with a much smaller sound footprint. Key features of the X-59 QueSST. 1. Supersonic speed. Without sonic boom, the X-59 can fly at supersonic speeds of over Mach 1.4, about 1,700 kilometers per hour, but with much lower noise, allowing the aircraft to fly over populated areas without disturbing the population. 2. Aerodynamic design. The long, slender nose, called the needle nose, and low-flying wings are designed to reduce air friction and allow for smoother airflow, reducing the shock waves that produce sonic booms. Third flight. Comfort. With very little noise, the X-59 allows for faster and more comfortable long-distance flights, without the disturbance of loud noises that disrupt the experience of passengers or people below the flight path. 4. Fuel efficiency. Although the X-59 is designed to fly at supersonic speeds, its fuel efficiency is higher than other supersonic aircraft, meaning it can fly farther without sacrificing excessive fuel consumption. 5. Advanced noise sensors. The aircraft is equipped with sensor technology that will measure the noise produced during flight. These sensors will provide critical data for testing and ensuring that the noise produced is as expected, that is, a sound that is not disruptive. Flight testing and testing. The X-59 QueSST project will enter the flight test phase in early 2025. Before the aircraft can perform supersonic flights over civilian areas, NASA will first conduct a series of flight tests to ensure the safety and stability of the aircraft. These first tests will focus on testing the aircraft's aerodynamics and controls in subsonic flight conditions, speeds below the speed of sound, to ensure that the aircraft performs well and safely under various conditions. After the aircraft successfully passes the subsonic test, NASA plans to conduct supersonic tests by flying over several areas of the United States. During this test phase, NASA will collect data on the noise produced and how the people below respond to the sound. As part of the test, NASA plans to survey residents living in areas that the X-59 flies over to determine whether the noise produced by the aircraft is audible or disruptive to their lives. The main goal of this test is to prove that supersonic flights can be carried out over civilian areas without negative impacts on noise. If the test is successful, it will pave the way for wider supersonic commercial flights in the future. Potential impact on the aviation industry. The success of the X-59 QueSST could change the paradigm of international aviation and have a major impact on the commercial aviation industry. It has the potential to significantly reduce international travel times, allowing flights between major cities thousands of kilometers apart to be completed in much shorter periods of time. In addition, the X-59 QueSST has the potential to revolutionize long-distance aviation by enabling supersonic flight without the noise impacts that typically hinder such flights. This would open up new opportunities for commercial aircraft capable of flying at supersonic speeds without disrupting the daily lives of people in their flight paths. Other companies in the aviation industry, such as Boom Supersonic and Aerion, who are developing their own supersonic aircraft, could use similar technology to create more efficient and environmentally friendly aircraft, positively impacting the global aviation market. The X-59 QueSST is a major step forward in NASA's efforts to develop quieter and more environmentally friendly supersonic flight. With its innovative design and advanced technology, the X-59 could be the vehicle that changes the way the world travels, reducing travel time between countries and opening the door to a new era of more efficient and comfortable commercial supersonic flight. Although the project is still in its development stage, a successful first test flight would be the beginning of a long journey towards more sustainable and more globally acceptable supersonic flight.